Hello everyone and welcome to Mathematics Scolio. So in this video, you will find a previous AIME problem that involves the concepts of function, sequence and progression, combinatorics. Looking at the intricacy of the problem, I will say that it is also important for JEE Advanced. Well, I will be sharing my approach of solving this beautiful question in this video. So let's start. So here is the question which says that for a real number x, let GIF, that means integral part of x, is the greatest integer less than or equals to x. Okay, fine. So this symbol they have defined. Further, they have defined the fractional part of x. Examples also, they are just explaining it, that what is the fractional part of x. Now they have defined the function f of x. Now what is this function f of x? F of x they have defined as x into fractional part of x, and let n be the number of real valued solutions to this equation. Look at this equation. This is the composition of function taken 3 times. f of fx is equals to 17 for x closed 0 to 2020. Find the remainder when n is divided by 1000. That means the question doesn't stop here. It takes a new turn, and then it says that you have to divide capital N by 1000, and then you have to identify how many solution or what is going to be the remainder when you divide n by 1000. So I'm just splitting my question into 2 parts. First of all, I will be concentrating on the first part of the question. Then I will move on to the second part of the question. So chaliye start karte hain. Let us start with the question. The question says that for a real number x, function f of x they have defined, which is nothing but x into fractional part of x. I'm going to define this function for few intervals. Till 2020, I can define it, right? But I'm not going to define it regularly for every unit length interval. What I'm going to do, I'm just going to write that when x belongs to closed 0 to 1 open, we know what is going to be the fractional part of x. So you can write down the function as x squared. If you take x somewhere between 1 and 2, obviously the fractional part of x will become x minus 1. So you can see that what we are getting is x into x minus 1. Now I'm moving ahead and defining it for the interval closed 2 to 3 open. The function will take the form x into x minus 2. Take it 2, 2. This is 1, 1. So I can say that when x belongs to, because in the question 17 is also important. So I'm defining it for 17 to 18 wala interval. 17 to 18, you will be writing down the function as x into x minus 17. Keep on defining it like this till you reach the interval 2019 to 2020 open interval. When you write it as 2019 to 2020 interval, the function will become x into x minus 2019. And lastly, for x is equals to 2020, also I need this function. So I'm just writing this for 2020. It will become 0. So here is the defining of the function, at least for closed 0 se lekar 2020 closed, right? Once I have defined this function, I'll read the question once again. They are saying that n be the number of real valued solution to the equation composition of f of fx is equals to 17. Okay, fine. So now I'll be taking the help of the graph of this function to continue my question. What I'm going to do, see, everywhere all the branches are quadratic and we can easily trace them. All these branches have one root at 0. The other one in the interval closed 1 se 2, it becomes 1. In closed 2 se 3, it becomes the other root as 2. The other root is 17. Here, other root is 2019. So we can easily trace this graph between 0 to 2020. So I'm just going to trace the graph now. So for that, I'm marking the y-axis and the x-axis. Let us mark the points 0, 1, 2. After that, I'm just marking 17, 18. The graph should not be scaled because I have to go till 2020 and I cannot trace it on the screen. So I'm just going like this. And then this is 2020. Okay. We are going to start with the graph, first of all, in the region 0 to 1. So 0 to 1, we have seen that the graph is going to be y is equals to x squared. One more thing that we can notice here is at 1, it takes the value 1. At 2, it takes the value 2. At 3, it takes the value 3. At 2020, it takes the value 2020. That means it approaches 2020 everywhere, right? So we can say that the line y is equals to x is going to help me in tracing the graph. So I'm just tracing that line y is equals to x so that I can trace the graph easily. Okay? So some portion, or in fact, this is the line that we have. So this is how it can be traced. With the help of this line, now I will be tracing the graph. So I started with y is equals to x square. Y is equals to x square between 0 to 1. Then between 1 to 2, the graph that has to be traced is of x into x minus 1. And ek root 0, 1 root is 1. So the graph will go like this. Then between 2 to 3, again you have to trace the graph, which will be having the roots 0 and 2. So 2 to 3, you will be having the graph like this. Between 17 and 18, between 17 and 18, I can say the graph is going to be like this. And similarly, 2019 to 2020, we will have the graph again something like a quadratic having the concavity upwards somewhere over here, and then this is 0. So we have the graph between 0 to 2020. You can see that in every unit length, the graph is increasing kind of graph that we are getting here, right? Fine. After tracing the graph, what we have to do? We actually have to find out the number of solutions, the number of real valued solutions of f of fx is equals to 17, right? We need to find out the number of solutions of f of fx equals to 17. Now, how we are going to solve this question with the help of graph? Actually, what I'm going to do here is I will be needing the graph from 17 onwards. So instead of considering this whole graph, let us trace this graph for 17 to 2020. Why I need 17? Because you actually have to solve the question for fx is equals to 17. And just now we have seen that at 17, the functional value is trying to tend towards 17 from left-hand side. Okay, this thing we noticed. 16 to 17, if you're defining it, the graph is going to be x into x minus 16. It will be tending towards 17 when it is approaching 17 from left-hand side. चलिए, अभी क्या करने जा रहे हैं हम? अब हम लोग इसी ग्राफ को जरा 17 से लेकर 2020 तक हाईलाइट करते हुए ट्रेस करते हैं. ठीक है, तो हाईलाइट करते हुए ट्रेस करते हैं मींस बिफोर 17 I will not be concentrating. We'll just be tracing the graph from 17 to 2020. That is also going to be just like the rough sketch. So for that also I'm tracing the line y is equals to x as the reference line. Now I will start with, first of all, 17. Okay, this is not 0 as such. I'm just taking 17 here. So let me just remove it from this side. ठीक है ना, ये ग्राफ आपके पास है, but this is not 0. Origin नहीं लिया है. This is 17. Y-axis has been shifted. Something like that you can assume. Okay, 17. Then we have 18. Then we have 19. Then we will have 2019. Then we will have 2020. Basically, I'm tracing the same graph, just highlighting the portion between 17 to 2020. ठीक है, so this is 16 also. 16 पे the graph will be something like this. 17 पे we will have the graph this portion. 18 to 19 में we will have the graph this portion. And then 2020, the graph at 2019 and 2020 is going to be like this, right? So this is some of the portion of the graph that I have traced. Some of the branches I have traced. For some of the interval, I have traced the graph. This is what I can say, right? This is the graph that we are getting. Okay, now what we have to do, we have to solve this graph. That means f of fx is equals to 17. How we are going to solve it? For the time being, I will be assuming that f of fx as f of capital X. That means this quantity I'm assuming is capital X, and I have to solve fx is equals to 17. So I'm just going to trace a line, a horizontal line y equals to 17. Chaliye, let's start. 17 means which point? You can see that this is 17. So I have traced the line 17. This is y is equals to 17. How many points of intersection are we getting here? Many points of intersection are there. You can see that between 17 to 18, you have 1 point of intersection. 18 to 19, may we have another point of intersection. Every unit length interval between two consecutive integers, I keep getting one solution, right? I keep getting one solution between every two consecutive integers. So can we count how many solutions are we getting for fx is equals to 17? It's very simple. Between 2020 and 17, there are 2003 solutions that we are getting, right? We are getting 2003 solutions over here. I'm just going to name those solutions as alpha 1, alpha 2, alpha 3. And when I solved f of capital X is equals to 17, the solutions that we are getting, I'm naming them as alpha 1, alpha 2, alpha 3, and keep getting it till alpha 2003. But this is not the answer, right? I actually have to solve f of fx is equals to 17. So I'm considering now the first case of alpha 1. The way we are going to handle alpha 1, similar way mein you are going to handle alpha 2, alpha 3 and alpha 2003 as well. So chaliye start karte hain. I'm assuming that let capital X is equals to alpha 1. I started solving this one. What does it mean? It means that you're actually talking about f of fx is equals to alpha 1. Okay? For the time being, I'm assuming this f of x as some capital Y. Yani f of y is equals to alpha 1 I have to solve. F of y is equals to alpha 1. If you want to solve this one, you just need to trace the graph of f of y, which is already there. And then a horizontal line y is equals to alpha 1. So I'm going back to the graph. We'll trace y is equals to alpha 1. But now the question is, where is alpha 1? So you can see that this is the point that we have taken as alpha 1. The corresponding y, alpha 1 kahan par aayega? This is alpha 1. I'm going to trace a line, horizontal line, at y is equals to alpha 1. See, I have traced it. This is y is equals to alpha 1, right? So let me just show you. Just look at this one. This is alpha 1. The line that I have traced here is y is equals to alpha 1. Again, you can see a point of intersection with all these branches till 2020. Again, I can see that between 17 to 18, I'm getting one point of intersection. Another one is between 18 to 19. Like this, till 2019, 2020, I keep getting one point of intersection in every unit length ka interval, right? In every unit length interval, we keep getting that point of intersection. Okay, so I'm just naming all these roots that now I'm getting corresponding to f of y is equals to alpha 1 as beta 1, beta 2, beta 3 till beta 2003. Okay, so I'm going to name these solutions as capital Y का values of हमारे पास क्या आ गया है? For alpha 1. For this equation, my answer turns out to be beta 1, beta 2, beta 3. Keep on writing till you reach beta 2003, right? But still, I don't have the solution right now because Y means you're actually talking about f of x. You're actually talking about f of x means now f of x will be taking all these 2003 values for alpha 1. When I take the case of alpha 1, I'm getting f of x as these 2003 values. That means I have to solve now these 2003 equations. Again, I'm considering first of all beta 1. Beta 1 means which equation I'm solving? I'm solving f of x is equals to beta 1. F of x is equals to beta 1 means, let us go back to this graph. I'm going to mark what is beta 1. So for that, let me just magnify this graph. And now from this graph, you can see that this is the point which is alpha 1. Alpha 1 ka matlab, sorry, beta 1, which I can write as, so here is the point beta 1 that we are getting. Corresponding beta 1 on y is equals to x if you want to trace, then how you're going to trace it? So I'm just marking it over here. This is beta 1, right? Ye hamare paas beta 1 aa gaya hai. This point is beta 1. Y equals to x hai, so beta 1 ke corresponding the y beta 1 is going to lie on y equals to x. Now what you have to do, you just have to trace a line parallel to x axis and solve it with f of x. Yani f of x is equals to beta 1 ko actually we are solving. So this is what we have to do. This is y is equals to beta 1. So let me name this line. This is y is equals to beta 1. And now from this line, you can see that, just have a look at this graph. From this graph, I can see that again, I got one point of intersection in the interval 17 to 18. Another one is in 18 to 19. Next one is in 19 to 20. In fact, again, unit length interval mein, we are getting one solution every time, right? Ye bhi ek solution aa gaya. So how many solutions are we getting for fx is equals to beta 1? If you talk about fx is equals to beta 1, then I'm getting 2003 solutions for this equation. Similarly, if you start solving fx is equals to beta 2, then you know that beta 2 का मतलब क्या हो जाएगा? The second solution. Which second solution are we talking about? This yellow line. Just look at this yellow line. This second point of intersection. This was beta 1, this is beta 2, this is beta 3, and then so on, right? So beta 2 ke corresponding, if you solve it in the similar way, you will be getting the similar kind of answer. But similar kind of answer means now the answer will not be 2003. Why? Because 17 to 18 wala interval will not be considered now. We will be getting the answer from the interval 18 to 2020. And every unit length pe, I will keep getting one solution. So for fx is equals to beta 2, if I start counting the number of solutions, so let me trace this graph as well. Beta 2 ke corresponding, I'm marking this one is beta 2. Trace a line parallel to x-axis passing through beta 2. You can see that now the point of intersection, the solutions that we are getting will start from here. 1, 2, 3 until 2019-2020 interval. We will be getting 2002 solution. That means one less than the previous one case. So let me write this over here. fx is equals to beta 2 indicates that we will be getting 2002 solutions, right? We will be getting here 2002 solutions. Similarly, now if I talk about fx is equals to beta 3, where beta 3 actually belongs to the next interval, 18 to 19 wala interval, now we will be considering, and then 19 to 20, and keep on writing it like this. Now my answers will be 2001 until the last case. Last case means when you're talking about beta 2003. When you're talking about beta 2003, then you will be getting just one solution. And I can say that when I solve the whole equation, which one? F of capital X. F of capital X means f of fx is equals to 17. I actually got 2003 point of intersection. I have to solve the equation for all these 2003 cases. I started with the very first case, alpha 1, which was actually belonging to 17 to 18 interval. When I solved it, x is equals to alpha 1 ke corresponding, ultimately I am getting how many solutions? This much number of solutions. Let us add them all together, and you can see that this is nothing but the sum of first and natural numbers. And that is the reason I'm writing it as 2003 multiplied by 2004 whole divided by 2, right? This much number of solutions I got when I consider the case of alpha 1. Similarly, when you consider the case of alpha 2, if you consider the case of alpha 2, then you know that alpha 2. Let me show you alpha 2. Where is alpha 2 in the graph? So alpha 2 in the graph is over here. This is alpha 2. So alpha 2 is in the interval 18 to 19. That means 18 to 19, one interval 17 to 18, that unit length interval is now missed out. And that is why if you proceed in the similar manner, the way we have proceeded for alpha 1, here the number of solutions that we will be getting will be 1 plus 2 plus 3, but only till 2002. So I can write my answer as this will be 2002 multiplied by 2003 whole divided by 2. For alpha 3, if you go similarly, your answer will become 2001 multiplied by 2002 whole divided by 2. Keep on writing it like this till you reach alpha 2003. Alpha 2003 means in that situation, we will be getting the answer 1 multiplied by 2 whole divided by 2. So when you add them all together, you will get the total number of solutions. So I have to solve that equation. F of capital X is equals to alpha 1, alpha 2, alpha 2003. Na? When I solved it for alpha 1, I got this much number of solutions. When I solved it for alpha 2, I got this much number of solutions. When I solved it for the 2003 case, I got this much number of solutions. Now I have to add them all together. But how we are going to add them all together? So on adding, I can say that my answer turns out to be sigma r into r plus 1 by 2, where r starts from 1. 1 means from here and goes till 2003. 2003 means this case. So r ka value starts from 1, 2, 3 up to 2001, 2002, 2003. Everywhere we have the similar pattern. So I have written it like this. I need to get the sum of this one. So now sequence and progression a little bit we have to use. This will be sigma r square plus r, right? or sigma r square plus r karke you can write. I will be writing the answer in terms of n. So this will become n into n plus 1, 2n plus 1 whole divided by 6. And sigma r means n into n plus 1 by 2, where I am taking n as 2003. But before that, let's simplify it. So when you simplify it, what you are getting is 1 by 12. You can also take n into n plus 1 ka factor common. We'll be left out with 2n plus 1 over here, and plus n into n plus 1 already taken common. So plus 3. What we are getting is 1 by 6 times n into n plus 1 multiplied by n plus 2. Now keeping n is equals to 2003. Now I am keeping n is equals to 2003. So let us see on keeping n is equals to 2003 what we are going to get. So we are going to get 2003. We will be getting 1 by 6 times 2003 multiplied by 2004 multiplied by 2005. So this is the value of capital N, the number of solutions for the given equation. But the question doesn't end here. We have to find out the remainder when this is divided by 1000. So if you are dividing it by 1000, what is going to be the remainder is the question. Okay, so now one way of solving the question is, first of all, definitely I'm going to simplify it. That means let us divide 2004 by 6. We will be getting here 334. And this is going to be 2005. So because now we just have to find out the remainder when it is divided by 1000, we are actually interested in getting the last 3 digits of this product, right? Whatever the last 3 digits we are getting for the product, that is going to be the remainder in the question, right? That is going to be the remainder for this number when it is divided by 1000. So now one way of handling the question is you actually multiply these 3 numbers and get the last 3 digits. But that is going to be a little irritating. I won't say we cannot do it. Yes, we can do it, but it's going to be a little irritating. So we are not following that method. Instead, what you can do is I have to divide n by 1000 and I'm interested only in getting the last 3 digits. So see what I'm doing. I'm writing n as 2003, but instead of writing 2003, I'm going to write it like this. 2005. See, I have written it like this. And 334, I'm writing 300 plus 34. Okay, so we are going to write it like this. Abhi, next what? Next, I'm just going to multiply these two. 2000 multiplied by 2000 will give me a huge number with the last 6 digits as 0. But I'm interested only in the last 3 digits, so I'll keep writing those last 3 digits. Okay. Then plus 5 into 2000 will give me the last 3 digits as 0. 3 into 2000, yes, we can write it, but I'm interested only in the last 3 digits, which are going to be 0. And then 3 into 5, the last 3 digits are going to be 015. It is only 15, so okay, it's fine. We can write it like this. You have to multiply it with 300 and plus 34. Correct? Now what? When we add them all together, we will get a huge number with the last 3 digits as 015. We need to multiply it with 300 and then plus 34. Well, interested only in the units place, or you can say last 3 digits, I will not be taking the tension of multiplying the whole number together. So I started with the product of these two. Just see, last bit is 15 and then you have to multiply it with 300. So last 2 digits, so definitely it's going to be 00. And then 15 into 3 is 45. So you will get 5 here and 4 will be carried forward. I'm not interested what I will be getting over here. The last 3 digits are going to be 500 or 500. Plus, when you multiply these 2 numbers, now you need to check what you are going to get at the last 3 places. So it is something like multiplying 15 into 34, right? Or you can say 34 multiplied by a huge number 015. So when you multiply it or multiply them together, what you will be getting as the last 3 digits? 0, 5, 1 and the huge expression. Right? So last 3 digits that we are going to get here is 510. Actually, what I did is I multiplied 15 with 34. I was getting 510. And after that, because other digits are also there, I'll be getting definitely some digits over here. Interested only in the last 3 digits. Now I can say that when I add them together, the resultant answer will be a huge number and we will be getting 0, 1, 0 over here. Now this is the number and you have to divide it by 1000. So this is capital N having the last 3 digits as 0, 1, 0. So when you divide N by 1000, then the remainder that we are going to get, the remainder that we will be getting here is going to be 10. So here is the answer that we have to the question. The answer will be 10. So initially the question was like this. You have to, or we started with the concepts of function, composition of function. Then we shifted to a little bit formula of sequence and progression. And we ended up with simple, we can say the common sense wala question. We divided it by 1000 and then we got the answer as 10. So this trick can be utilized for getting only the last 3 digits over here and get the answer. So this is method 1, my approach of handling the question through the approaches that we also learn in, or that we also study for the preparation of JEE Advanced. Now let us solve the same question with another method as well. Another method is for getting that value of capital N, because after that I'll be proceeding with the same approach of getting the remainder. So I'm just sharing another method in which we will be getting the value of capital N using the combinatoric approach. So chaliye, let's see what is that approach now. So for that second approach, we need to go back to the graph. So I'm taking you back to the graph over here. So here is the graph as you can see. The second method is almost similar to this previous one. The only difference will be here I actually counted the number of solution by expanding everything or elaborating everything. Now the same thing we are going to write with the help of combinatorics. Okay. So what we have to do is basically we have to solve this equation. F of fx is equals to 17. And we have to find out the number of solution. One thing we noticed here that in every unit length interval, we were getting every time one solution. That means whenever you are considering an interval of length 1 with the endpoints as integer, every time we are getting just one solution, right? I wrote those solutions as alpha 1, alpha 2, beta 1, beta 2. Okay, I have written that. And then I proceeded by calculating each and every case, the number of solutions in each and every case. Here, what I'm going to do, I'm just going to write them all together. How I'm going to write them all together? So let us see. We have to start with solving f of fx is equals to 17. Again, I'm considering f of capital X is equals to 17. And I know that if I start solving this equation, I will keep getting one solution in every unit length of the interval, right? So I can say that for every a, or you can say that there exists some integer a which is greater than or equals to 17, but obviously it is less than 2020. We know that 2020 is not the solution, so there is no point of considering that one. So I can say that there exists an integer a greater than or equals to 17, but at the same time less than 2020, such that for every interval a, say a plus 1, for every interval a to a plus 1, I will be getting one solution, right? For every interval a to a plus 1, I'll be getting one solution. Now, suppose you have selected a as 17, then what we are saying is between 17 to 18, I'll have one solution. If I take a as 18, then I'm saying that between a 18 to 19, I'll have one solution. So, okay, fine. I wrote all those solutions as alpha 1, alpha 2, alpha 3 over there in the method 1. Here, I'm just saying that for every this interval, I will be getting one solution. How many such intervals can be taken? 2003. It's one and the same thing. A ka value 17 se start hoga. It will go up to 2019. So total 2003 cases will be, or 2003 such intervals can be taken. Okay, fine. So now for any particular value of a, suppose I have taken a as 17, then I have to proceed with this equation. And I will say that corresponding to this value, now the equation f of fx is equals to alpha 1 is to be solved. Alpha 1 means I'm just referring the same figure. So f of fx is equals to alpha 1 ke liye now you are solving. So if a is 17, this is the equation that we will be solving. Basically, we wrote it as f of capital Y is equals to alpha 1 in method 1. Now, for this equation, again, the same situation is there. I will say that there exists some integer b which is going to be greater than or equals to 17. Why 17 in this situation? Because alpha 1 belongs to the interval 17 to 18, right? Otherwise, I will write in general that b is going to be greater than or equals to a, but less than 2020. That means for this equation, there exists an integer b greater than or equals to a and less than 2020, such that for every interval b to b plus 1. Okay, for every interval b to b plus 1, I will keep getting one solution of this equation, right? In every interval of this kind, I will keep getting one solution of this equation, just like the previous case. The only difference is now we have considered f of capital Y. Alpha 1 is actually belonging to a plus 1. So b is going to be something which is greater than equals to a and less than 20. So let me give you an example. Suppose मैंने b को यहाँ पे 17 ले लिया. If I take b is equals to 17, then what I am saying is for this equation, I will have one solution in 17 to 18. If you take b as 18, you will have one solution in 18 to 19. And like this, if you take b as 2019, then you will have one solution for this equation in 2019 to 2020, right? But still the question is not solved because till now I have not solved it for x. Till now I have solved it only for capital Y. 3 times composition tha. So now let us continue and proceed. Assuming that for b is equals to 17, the solution is beta 1. Okay, if I take b is equals to 17 in this situation, we know that we had taken it earlier also as beta 1. So I'm taking it beta 1 here. So I'm solving it for y is equals to beta 1. What do you mean by y? Y means we have taken f of x is equals to beta 1. F of x is equals to beta 1, where beta 1 once again is belonging to the interval 17 to 18, right? If I take b as 17, beta 1 was the root which was actually belonging to 17 to 18. So again, the same situation you are facing once again, that how many solutions you are going to have for this equation, where beta 1 belongs to 17 to 18. So same explanation say again, I can say that there is going to exist an integer c, which will be greater than or equals to 17. But in general, I must write it as b, right? b ko 18 lenge, so I'll write here 18. If I take b as 19, I'll write here 19. So in general, I can say that c is going to be greater than or equals to b, but at the same time less than 2020, right? So c has to be greater than or equals to b, less than or equals to 2020. There exists an integer c such that in every interval c to c plus 1, in every interval c to c plus 1, I will be getting one solution for this equation, right? We will be getting one solution in every this interval where c will be greater than or equals to b, but less than 2020. So see, in the previous case, I was actually counting by tracing the graph and counting the number of points of intersection in every situation. Here, instead of tracing the graph, we are just explaining it with the help of combinatorics. We are just writing in general that every interval of this kind will contain one solution. Now, how many solutions I'm going to get? So I will say that for every combination of 1a corresponding to which 1b and 1c. So every combination of this triplet ABC will give me one solution, right? Suppose a ko 17 liya, then you're taking b is equals to 17 and c ko also you are taking 17. So in that situation, you are getting one solution. Suppose a is 17, b ko I'm taking 18. So in that case, beta 2 is the solution you are actually considering. Then you are taking c as 18. Again, I will get one solution. So every combination of ABC is going to give me one solution. Where ABC, what is the relation? A is greater than or equals to 17, less than or equals to B, less than or equals to C, less than 20. So we can say that my question has now reduced to finding out the number of triplets ABC in the set 17, 18, 19 to 20 open interval which satisfied this condition. So basically we have to select 3 integers which are forming the non-decreasing set or non-decreasing triplet, right? So ABC are to be selected in such a way such that they are forming a non-decreasing series, and it has to be selected from 17 to 20. That means basically जो set available है, the available set में entries are 17, 18, 19 until 2020. So 2003 entries are available, right? There are 2003 entries, or you can say 2003 elements are there in the set. And from these 2003 elements, I have to select 3 numbers which are non-decreasing. What are the possible cases? Normally in this case, answer turns out to be 2003 entries. So you have to write 2003 plus 2, C3. That means answer turns out to be 2005, C3. But let me elaborate it a little how we got this answer. So that is why I'm writing the cases. First case, we can assume that we are taking A is equals to B equals to C. So A equals to B equals to C means out of 2003, you just need to select one entry. All of them are equal. Second situation can be A greater than equals to B, but B is equals to C, and A greater than B. So A greater than B equals to C means out of 2003, I actually have to select two elements. The greater one will be A, the smaller element will be B. So can be arranged in only one way. Third case I'm considering when I'm taking A is equals to B, but B is greater than C. This is also a possibility. So you have to take two elements out of 2003. 2003 C2 again can be arranged in only one way because the smaller element will be C and the greater element will be A and B, right? The fourth case that we can take is A greater than B greater than C. In this situation, I actually need three elements from the set which are to be arranged in decreasing order, right? So हमें decreasing order में उसे arrange कर देना होगा. So हमारे पास क्या आएगा? हम लोग ये कह सकते हैं कि non-increasing. I think I was saying non-decreasing. A has to be. So A has to be less than B. So this has to be corrected over here. I'm going to correct over here. Okay, this is the situation that we have. So, okay, fine. This is the situation that we have. So, how many answers now we will be getting? We will get 2003 C1 plus 2003 C2 plus 2003 again C2 and then 2003 C3. Adding these two together is NCR plus NCR minus 1, which is N plus 1 CR. Right? I can write it like this. Similarly, when you add them together, it will become NCR plus NCR minus 1. So basically, adding them together gives me N plus 1 CR. Again, the same situation, NCR plus NCR minus 1. So answer will be N plus 1 CR. So 2005 C3 means again you are getting 2005 into 2004 into 2003 whole divided by 6. Cancel this one. So we are actually getting the value of N the same as we got in or using method 1, right? So this is alternative way of getting the value of N. Now after this, what is going to be the remainder means again you have to concentrate on getting the last 3 digits of this product. So you can proceed the way we have proceeded in the method 1, right? So hope you enjoyed this question. If you enjoyed it, then please like the video, share the video with your friends and fellow aspirants. And if you have not subscribed to the channel yet, then please subscribe it. So thank you all of you for watching the video. See you in the next video. Till then, bye-bye.